Hey everyone, and welcome. Today we're going to dive into a topic that, well, a lot of us remember from school, but maybe still find a little bit tricky. We are talking about fractions.
So let me ask you, be honest, when you hear that word fraction, does it make your palms sweat just a little bit? If it does, I promise you are in good company. For so many of us, fractions can feel kind of intimidating, even long after we've left the classroom.
Seriously, that feeling is incredibly common. But here's the thing, the actual idea behind fractions is beautifully simple. So today, we're just going to strip away all that old school anxiety and take a completely fresh look at them.
And that anxiety? It can lead to some really big misunderstandings. Get this. A study found that a staggering 83% of college students actually believe that all fractions have to be smaller than the number 1. We're about to see exactly why that's not the case at all.
So let's go right back to square one. Let's forget all the complicated rules for just a minute and really rediscover the simple, powerful idea at the heart of what a fraction really is.
You know, the biggest clue is hiding right there in the word itself. Fraction comes from the Latin word fractio, and it just means to break. That's it. At its core, that's all a fraction is. It's a way of talking about breaking a whole thing into equal parts. That's the whole idea right there.
Let's use the most classic example of all time. We start with one whole pizza. It's a single, complete thing. Easy enough, right?
Now we do exactly what that Latin word told us to do. We break it. We slice it up. And here's the golden rule, the most important part. All of the parts have to be equal. So in this case, we made 8 perfectly equal slices.
And voila! Each one of those equal parts is now a fraction of that original whole pizza. So this one single slice, it represents one of those 8 equal parts.
Okay, so how do we write this down? Well, it's all about 2 numbers. The bottom number, we call it the denominator, tells us how many total equal parts we broke the whole thing into. For our pizza, that's 8. Then the top number, the numerator, tells us how many of those parts we're actually talking about. Right now, it's just that one slice.
And this whole idea of breaking things up, it's not new, not by a long shot. We're talking ancient. The Egyptians were using fractions to share food almost 4,000 years ago. The way we write them down has changed over the centuries, evolving from India to the Arab world until it became the simple form that we all recognize today.
All right, so now that we get the basic idea, you should know that not all fractions really look the same. You can kind of think of them like a family with a few different members, and each one has its own name. So let's meet the main types.
Okay, there are 3 main types you'll run into. First, you have your proper fraction, like 3/4. This is what most people think of. It's less than one whole thing. But then you've got improper fractions, like 5/4, and these are actually more than one whole. This is the one that tripped up those college students. And finally, you have a mixed fraction, which is just a whole number hanging out with a proper fraction.
Next up is a really cool idea called equivalence. And all this means is that some fractions can look totally different on paper, but they actually represent the exact same amount.
Think about it like this. Would you rather have 1 out of 2 pieces of a chocolate bar or 2 out of 4 pieces? It's the same amount of chocolate, right? Of course it is. Well, that is all equivalence means. 1/2 and 2/4 are what we call equivalent fractions.
All right, you with me? Good. Let's put this knowledge to work. What actually happens when we want to combine, add different fractions together?
Let's take a look at this problem. Now, your first instinct might be to just add the numbers straight across, but you can't. And why not? Well, because the slice sizes are totally different. 1/3 of a pizza is a way bigger piece than 1/6 of a pizza. We can't add them until they're the same size.
Luckily, there's a simple little 3-step recipe for this. Step 1, and this is the most important part, is you have to make the bottom numbers, the denominators, the same. Step 2, once they're the same, you just add the top numbers, the numerators. And step 3 is to simplify the final answer, if you can.
So, to solve our little problem, we need to make those slice sizes match. We can do that by turning 1/3 into an equivalent fraction, 2/6. See? Now both of our fractions are talking about sixths. They're the same size, so now we can finally put them together.
Now that the denominators match, the hard part is over. Seriously, the rest is easy. 2/6 plus 1/6 gives us 3/6. And hey, just like with our chocolate bar, we can see that 3/6 is really just the same as the much simpler fraction 1/2.
So, okay, why does any of this matter outside of a math class?
Well, the truth is, once you start looking, you realize this simple idea of breaking up a whole it's literally everywhere.
Just think about cooking. Every single recipe you've ever used is basically just a list of fractions, right? A half cup of flour, a quarter teaspoon of salt. Getting those fractions right is the difference between a delicious cake and, well, a brick. Or what about music? The entire rhythm and feeling of a song is built on fractions. A whole note, a half note, a quarter note. It's all about dividing a bar of music into equal pieces of time.
And here's one that's absolutely critical: medicine. Getting a dosage right is everything for a patient's safety. Calculating the correct fraction of a medication can, quite literally, be a matter of life and death.
So you see, from splitting a bill with friends to figuring out a sale at your favorite store, fractions aren't just numbers on a page. They're a tool we use every single day to make sense of the world. So the only real question left is, where are you going to spot one next?